After this mid semester, the module what we will cover here, that will be looked slightly in different angle compared to the things which we were seeing or we were discussing about digital image processing in a particular angle there, where you have found there that briefly if I speak those, like we started knowing about how digital image will be represented and how the spatial coordinates for individual intensity values which by which an image is presented, that is to understand, and then how to tackle them if we want to make some arrangement of different coordinate system or transform them from one coordinate system to another, or to analyze the image by using different tools like discrete Fourier transform, discrete cosine transform, or in statistical manner. This way, those were basically we were learning the tools which we were in a plan to use in those applications which will be discussed now after this module, what we have discussed before mid-sem there. So, from here onwards till the end of this module, we will see that those techniques or those tools are how they involved in our different processing or different image processing in different applications there. Okay. So, in that first application what we will be discussing here, that is image enhancement. This image enhancement, if I want to introduce quickly in this slide, through the image representation what I have put here for the first image, top one, leftmost one, figure A if you see there, that is an image where you are seeing appearance is there of the image, but some darkishness is there in that, but that is not suitable for us. We want to enhance that or improve the image in some manner. I am saying in some manner or in some extent, up to some extent, that is very important with respect to the term enhancement. In this, I will not able to tell you that how much I could able to enhance or what is the quantity value of it of enhancement, that I will not able to say. I will say only subjective way, like some better, little better, or far better, or very good, or good, like this. So, these are all subjective measurements. No objective measurements can be given for this topic, where we will be talking about image enhancement, which can be tackled in different manner, but still if I am saying enhancement, that is actually the subjective measurement I am talking about. Okay. I will speak this again while we will be proceeding for the discussion on enhancement there, but at the beginning as an introduction, if I have enhanced the image by some manner which was presented as figure A there, and that has appeared to us as B, which is better than the previous one. Similarly, for the next image if you see there, this is better prominent compared to the previous A, obviously of different image it is, but it is better visible, but still there some scope is there to enhance it, which is given in the B image. So, how to do this, which way to be done these things, those will be learned in this first topic of image enhancement. Okay. So, if this is the image enhancements I am talking about, or we are now got introduced about, which way this can be done, I will crudely make two differences here. One is by doing operation in spatial domain or by doing operation in frequency domain. These are the two different ways through which we can make the image enhancement in some manner which is better than the earlier or far better than the earlier, or some subjective way we will define the betterment of the image there. Okay. So, first we will discuss about the spatial domain enhancement techniques, and then we will go for frequency domain exhaustively. Okay. So, first I will get into the subject of image enhancement in spatial domain. In doing so, spatial domain if I am talking about, that means I am talking about the spatial coordinates which are there in the real image presented in front of us, where the real coordinates what I am talking about are centimeter or millimeter or in terms of length. The real image which is given with their spatial coordinates at different coordinates, different intensity values are there, so the image appears in different manner. I am talking about that spatial part. And if I talk about frequency domain, that means I will transform that spatial domain image into frequency domain, then I will try to transform it or enhance the image in desired shape or desired form what we want. Okay. Things can be done, same work can be done by operating on the image either in spatial domain or in frequency domain, where correspondence between those two I will be drawing in our lecture. Not today, but in another lecture there. Okay. So, let us start with the topic image enhancement in spatial domain. That has also many parts there, we will be going one by one there. And for today, we will be discussing about those headlines which are marked in blue, and then remaining which are also a spatial domain transformation, which will be discussed next to this one in the another lecture. Okay. So, now if I say about image enhancement in spatial domain, that means first, since I am saying spatial domain, the spatial coordinates are coming in my mind. That means the x and y coordinates by which I represent the spatial location of the image and their pixels which are giving some intensity value there, so that one image is appeared to me. Okay. So, those spatial coordinates I am talking about, and then if I locate a particular spatial coordinate, that particular coordinate will have a particular intensity value. That intensity value may be color, may be black and white, or in any gray shade. Okay. So, now if I am saying gray level transformation, that means I am talking about if that gray value is there with a particular specific value, I want to transform it in another way or in another value. Which way I will transform, that is another issue, but I want to transform that intensity value which is there, which is represented now, which is saying here now gray level or gray value in this slide, that value I want to change in another form through some transformation. What are those transformation? Those will be discussed one by one there. First, I have chosen the basic gray level transformation like image negative, log transformation and power law transformations, which will be discussed today, and next we will go for further betterment of those transformation techniques there, where piecewise linear transformation, gray level slicing and bit plane slicing also will be considered in our module. Then we will go for slightly different compared to those techniques which are highlighted at the beginning, which is known as histogram equalization. By means of the histogram analysis or statistical analysis, we can enhance the image in spatial domain again. That will also be discussed here. And finally, we will move to the topic spatial filtering, which is the more fundamental technique for image enhancement or image processing, I will say in general. Means all the transformations I can now move to its shape, where spatial filtering or filtering I will say, so that it fits to both spatial domain and frequency domain. But we will start with discussion on spatial domain first, where smoothing and sharpening of the image will be done, and then the same things will be done in the frequency domain, so that our understanding will be complete in image enhancement through spatial domain transformation and frequency domain transformation. Okay. So, let us move. First, let me introduce the way we will tackle the matter here while representing the image transformations or transformation functions in our image processing. This is purely image processing I am talking about. Earlier, we had only have some idea about spatial coordinates, their intensity values. Without changing the intensity values, we were trying to change their coordinates value from one place to another place, so that image was getting tilted or shared, or it was zoomed, or it was shrink this way. We did not distort the intensity values there. But now, compared to that, this is far more inner thing of the image which we are trying to handle there, where we will try to manipulate the absolute intensity values of the image, which we did not do in our previous module before mid-sem. This is the difference. So, please be tuned with that we are now going to process the intensity values directly. Okay. So, let us start from the beginning. Say fxy is the intensity value for a particular image coordinate x and y. In that, intensity value is represented by f, and it is a function of the spatial coordinates x and y. So, it is represented as fx comma y. Now, that intensity value is to be transformed in another value or transformed an image into another shape by tackling each and every fxy, where x can run from 0 to m minus 1 and y can run from 0 to m minus 1 again. So, throughout the total image, on that one transformation function capital T is applied there. Capital T is the transformation function which you will be defining there. Quickly, if I give you one example, what kind of functionality it can have, this T? Say like capital T is a multiplication of 2. That means all the intensity values will be multiplied with 2. That means intensity values will be becoming double. T can be a logarithm function also. So, I can say this T is an operator which will be operating on the fxy. Now, which way? Those techniques should be defined there one by one, what I have planned in this lecture today. Okay. So, I am basically focusing on this capital T which will be operating on fxy, so that image is transformed to a particular shape or desired manner. This is actually image transformation, which is for enhancement we are discussing here. But you can transform the image for any purpose, does not matter. Now, how to define that capital T so that I get that function, I get the operation in a particular manner, that to be learned here. Okay. So, say after transformation, I have got the intensity value of that particular xy coordinate. Now, which was earlier fxy, now it has got changed to gxy after some transformation capital T there. Okay. Now, I am saying here basically about the intensity value. And xy coordinate, it is implied that for a particular coordinate value, I am talking about the intensity of it that is to be changed. Say now onwards, we take small r as the intensity value of a particular location xy. Now, xy can vary from 0, 0 to m minus 1 comma m minus 1 anywhere. Okay. So, r is the intensity value of the actual image which is to be transformed through the transformation function capital T, and that gives gxy, which will also have intensity value, say represent it as S. Sometimes people say that is the output image. That means in between an image was there that is put to a system, to the system for processing, and that is the input image which has the intensity value R, and after transformation or after operation the system output has come S. So, sometimes people say R is the input image and S is the output image or image intensity value. No need to worry on that. It is exactly the transformation which you are talking about, the black box through which you have passed the image for transformation, that T is that one. Since we are talking about image processing, we are basically talking about the capital T. Okay. So, let us represent the processed image S as transformation of small r, which is the intensity of image, intensity value of a particular coordinate xy, which is highlighted here in this image as xy as a dark part which is given there, just like it is a pixel at the center of that square. For that, the intensity value is R represented, and that is the pixel of an image for which I may take a small window which has 3 by 3 of its dimension, and center of it I have considered as xy. Now, that xy can be anything. So, that window will be moving from one place to another place, or if you do not want to consider that particular window, still you consider a single pixel of xy there, and for that the intensity value is R, and you are transforming it to S through T. Okay. This is about the definition of the terminologies which will be used there, but fundamental thing is that capital T is to be understood carefully. Okay. Now, say let me take one simple example of capital T, which is a function of R. R means intensity value of the input image or the actual intensity value which is to be transformed to S there. Okay. Now, if I want to know T, that means what? Through a black box something is passed and it has given one output there. Now, if I compare the input and output, I can guess something about the black box. This is the idea behind. To know about the black box, is it register or it is diode? How you will know? You will do some experiment and where you will be seeing that input is given something and output is found something. Now, find the relationship between input and output so that you get the idea about the system through which you have passed the signal, okay, with the same idea. Now, let us plot a graph between output and input. Output in the y axis, which is the dependent one, and independent variable is the input image, which is the R in the x axis. Okay. So, this graph is represented between a S versus R plot, where this curvature is representing say capital T R. So, can I say this capital T R, the graph which is presented there, that is nothing but the transfer function capital T. Okay. Now, we should not stop here only. It is an arbitrary function I have defined for capital T, which is a function of R. This is a function, but what the function is speaking about, that is to be understood, so that I can talk about the processing on the input image. Okay. So, let us proceed from the 0, 0 coordinate. If from left hand side to right hand side I proceed, what are the R values? They are increasing from 0 to highest value. Say I have L number of quantization levels or L number of levels which can be used for defining the small r. That means 0, 1, 2 up to capital L minus 1. Just like for bit depth 8, we had 256 number of levels which we defined as 0, 1, 2 up to 255. It is like that. So, r will be varying from left to right from 0 to 255, where 255 is the L minus 1 here. Okay. Now, say y is also varying from 0 to L minus 1. That means the output image what you will get, that also will have the intensity levels from 0 to 255 or total 256 number of levels. Is it practical? Is it attractive? Yes, I will say it is attractive, because without demanding anything, with the same number of gray values or with the same bit depth, you are able to do some operation or you are able to do enhancement for this particular example what we are taking here in this lecture. So, being within the same limit, we are trying to enhance the things there. So, it is quite practical that I will keep S variation from 0 to capital L minus 1. Okay. So, both are same. Now, if I would have this TR function a straight line of angle 45 degree, that means slope is 1. What would be the output? Input would be the output would be the same as like input. Okay. But this is not the straight line. This has some curvature there. If it is not so, what does it speak? Just like if I move from 0 to a certain level of R values there, even though R values are more than 0, but still the output is 0. Just like up to this, if I consider whatever be the input image value are there, output will be always 0. Similarly, if you go for the end, if R goes beyond this value, outputs will be the highest value L minus 1. Does not matter whatever be the R values were there after that as the input there. Okay. So, that means you have transformed the image to have their intensity values within the limit of this to this. Is not it? So, the output intensity values will be varying from this to this, but through a non-linear curvature. Is not it? How? Even though the input levels are growing very high, going to higher value there, but output is not growing that high like it is varying in this stage where the slope is higher compared to the beginning. But I want that way to transform. This for example I have taken, which way to tackle, that is another issue, and where I will use it, it is another issue. But if it is the curvature, in that they are saying that don't increase the input intensity values so high at the output at the beginning when it is rising beyond this particular value. Then after it reaches this value, then go very fast. Or in other way I will say, of this nonlinear curve I will find a center there with respect to this center like m value. Around it make the highest variation, and when you go far from it you make the variation at the output with respect to the input with lesser rate. This is the meaning. Or with respect to this m, if r is less than m, then you increase the s with respect to r at higher rate compared to that in the r ranges which are beyond or more than small m. That means if it is going very bright, don't make that bright, suppress it little bit. But less than m if it is, then if it is lesser r value, then you push it up and up. This way you can manage the curvature here as per your desire, which way you would like to appear the image after processing. Okay. So, can I say in this image, in this transformation, if this transformation is applied to an image, in that the lower dark values which were there in the actual image, that will be suppressed towards 0, and those who are very high values, they will be uplifted to the higher bright values there. That means what? The images which were having lesser contrast there, those will be now stretched up, because contrast is nothing but the difference between two intensity values. But here you are, if it would be a straight line, nothing would be happening to it, but here you are trying to stretch the intensity values at the output with respect to the input there. With more simplified example, if I take, let us make this nonlinear curve into another form which is given in the B, where you have fixed the threshold at m. Now you are defining the function this way, that if the input gray values are less than 0, less than m, make them all 0. If it is more than m, then make it highest or bright or L minus 1. So this is nothing but a binary image. Even though the intensity values were there not 0 but close to 0, now they are pushed to 0, and those who are higher than m value, those were not that bright, but still I have made them bright, maybe for some purpose. But transformation function which is defined there as capital TR, that will do that one. That means if you do a operation to make one image to binary, this kind of transformation function is there for you, you have applied in the system there, where you have applied the input to that system and output has come as a binary image. And for that, if somebody asks you what is the transfer function or transformation function for that system, you will say the curvature is like this. Okay. So this way, to define the transformation function capital TR, I will define the processing what I want there. Now what is the mathematical form of this TR, on that the processing will be defined, that is fine. But why? Why should I define the capital TR in a particular mathematical shape or in a particular mathematical form there? That might be the question, is not it? If capital TR is given with by a particular mathematical function, why specifically that mathematical function, not the other? That is the clue of image processing. If I want to do that, obviously something is there in my mind. What are those? Let us do. Say I have defined that capital TR of this functionality which are given in the graph there. One is a straight line not going from 0 to L minus 1 L minus 1, not going from 0 0 to L minus 1 L minus 1, but the straight line has gone from 0 L minus 1 to L minus 1 comma 0. If it is so, say this is the TR and this is a system through which you are applying an image which has the intensity values are there. How the output will become? Meaning of this curve is not it like this, that if the input intensity value is 0, output intensity value will become L minus 1, is not it? If the input intensity value is L minus 1, output intensity value will be 0. That means if it is the lowest at the input, output will be the highest. Is not it the inversion? Is not it like the NOT operation what we did earlier? This will be called image negative. So, image negative, if you want to obtain, the transfer function TR is to be defined in that curvature. Okay. Similarly, if I go for another function like log transformation, that capital T R is a logarithmic function. That means I am operating on R through a mathematical function log. Okay. If it is so, the curvature for the log which is given there, that I will follow. But I said you, we will not stop to that curvature only. If I have defined that curvature, for what purpose I have defined, that is to be understood very carefully. Now, please concentrate on the curve log. If it is given that way, now input image intensity value, if it R varies from lower values to higher values from 0 to L minus 1, which way the output will vary? At the beginning, means for the lower R values, the rising of output intensity values is not is so sharp that for the R values which are for higher than earlier value, means just like towards L minus 1, those are at the rate lesser. Is not it? The curvature goes this way, that for lower values, the push of the intensity values at output image will be more compared to the higher R values. Purely the meaning of the curvature I am talking about. So, that means if I want in some image to push the lower intensity values to higher, not that much for the higher intensity values. What might be the purpose? Purpose like, say, my main informations in a particular image is lying in the lower intensity values compared to the higher, but that is not that much visible in the actual image. So, I want to enhance it through some transformation capital TR. So, in that case, I will ask you, please go for the log transformation so that lower intensity values will get more prominent to your image there. This might be the reason. The opposite thing if I do, say things have occurred oppositely, like the higher intensity values are to be dominated there more compared to the lower intensity values which does not have much information for our desire. In that case, I can go for anti-log. So, the curvature also for the anti-log says like that the lower intensity values will not be pushed up much, but the higher intensity values will be pushed more. Okay. But for log, what kind of operation do you do? Either base 10 or base E. You do not have much flexibility there. Why not to go for anything like of any slope if you want to transform an input image to output. So, for that those power laws are there which will be discussed after this as a power law transformation at the end. Okay. Let us first move for the image negative. I have taken the example which we have already discussed in our earlier class there. We discussed there that if 170 is to be used for NOT operation, that is nothing but 255 minus 170, or it is 85, or finally S was nothing but 2k 2 to the power of k minus 1 minus R, or nothing but capital L minus 1 minus R. Now, I have picked up that final expression S equals to L minus 1 minus R there. What is L minus 1? This is the highest intensity value. And what is R? R is the intensity value of the input image. So, if I am talking about image negative, that means I am trying to invert the image. That means those which were bright now, they will be appearing as dark, is not it the negative of the image which was earlier we used to use for analog cameras there. First the negative will come, then we will develop it to get the positive image. Okay. So, that operation is nothing but the operation through which that TR function we defined there in the earlier graph there, which were going from 0 L minus 1 comma to 0 L minus 1 comma 0, that curvature. Okay. So, that is the image negative transformation which is used here, that is nothing but this S equals to L minus 1 minus R, and that TR, this function is defining a particular function TR, that is called image negative transformation or image negative transformation function there, capital TR. What is the use? Use is like many things are there, like if you want to highlight the white part from the dark image where dark is so dominating that white part is also getting overlapped there. In that case you can make the image negative, so that you get the better appearance of the image there. That way negative transformations are useful, and implication of this or implementation of this, which we have already taken earlier, if you do for the logical NOT operation, you will get the negative option nicely there. Because not only to define the transformation function TR there, also to how to implement it in the practical system, that is also another issue will be there always for us. Okay. So, now go for another transformation which is a log transformation. In this log transformation, you would see the expression there, capital S is equals to C log 1 plus R. I will not ask you to take that expression at the very beginning. Please take it as S equals to log of R, because I talked about log transformation. S equals to log R, then things are done. But in that R, is not there chance of coming R as fractional value? If R is fractional, then the negative value will come into picture, which we do not like to consider in our image presentation, because for that we have to again do for scaling there, and we have to push that up to the positive values. So, to take care of that, let us add 1 with it, so that it is not R but 1 plus R, that way that 1 has come. Basically it is log R, okay? That 1 has come that way. Now, after you take the log transformation, say the intensity values are transformed through log, that is fine, but still after transformation of log, say curvature is there with logarithmic function, but the absolute intensity value that is to be pushed up or slightly another value is to be taken there, say. In that case, small scaling is made there, small multiplication factor is considered there, which is C there considered as a constant. It is up to you. You consider capital C as 1 or any other value as per your desire. Okay. C is a constant. Basically it is a log of R, and remaining things are along with it for shaping the actual intensity value, nothing else. Okay. Now, if I do this kind of operation, just like log operation in this example, what it basically does? To have the proper filling of it, please take this image A. This is the actual image. Basically it is a spectrum of something, but I do not want to concentrate on the spectrum right now. Say it is an image given to you which has R values presented there, small r. Now, this is log transformed and the output image has found as B there. What is the difference? If you minutely look into the image A, there maybe you are able to see some variation of gray values, black and white is there near to the center, but those are not that prominent. But still it is there, you can guess at the center, but go away from the center. Other than those horizontal and vertical axis there, remaining places are almost dark when you move far away from the center there. It was appearing to you this way, but somebody has said you no, in that actually minute variation of the smaller intensity values or smaller gray values, there only the information is lying. So, I want those to extrapolate or those portion to enhance. So, for that they have done this kind of operation where they have directly taken this intensity values for each and every coordinate x y of this actual image. They have taken the x y coordinate of a specific value, they have taken the r there, they have added with 1, but taken a logarithmic function of it, multiplied with c, and those they have presented in the second graph, nothing else in between, because only r is involved in the logarithmic function, nothing is done other than this. Purely it is in your reach, you can take the intensity values and do this operation, you will get the image output that way. Now, you see there with a small operation of this kind has made the image like completely different from the earlier, where those bright portions have come till the corners of the image there. How could it happen? So, if I want to know how it could happen in this fashion, I have to go to the curvature. Now, see the curvature of logarithmic function. There if you see the lower intensity values which are there, they have pushed up more to give the higher intensity value as S, but the higher intensity values at the input image they are not pushed that much at the end for higher R which are presented in the curvature. If you see there, the curvature has gone this way. Okay. So, the rate of change of the intensity values or the intensity values of lower values, they are pushed more there. So, the dark portion which was there in between those which were having lower values, they are now have got higher and higher values there. So, that they make their existence prominent in the image. Earlier those were suppressed by the other dark values which were close to them, but because of this nonlinear function or nonlinear functionality of logarithm, things have come this way. So, it is very much useful in practice. Okay. One more example, one more interesting application of this. Like say you want to enhance an image and along with that you want to present the image with a lower dynamic range. Like you have the dynamic range from 0 to L minus 1, means 0 to 255 say, but you do not have that much scope of considering that big scale there, but you want to concise your output gray levels from 0 to 300 say. That means the range where you are moving from the input image now you are allowed to use only 0 to 300. That means dynamic range has to be compressed. In that case, this logarithmic function can easily be used there, because I am seeing there for the output images the push of the input gray values are not that prominent like which is happened for the beginning there. That means the variation of the intensity values which are here as prominent are of lower values, not the higher values. So, now if you adjust the logarithmic function so that the higher intensity values after a particular R, those are all bright. So, that means beyond that you do not need to go at all at the output image where those are of having very less information content in them. Okay. So, that way depending on the curvature you can, by using a logarithmic function or its base, you can adjust the dynamic range on which you want to lie in your output or processed image there through transformation of called logarithmic transformation there. This is another advantage of this logarithmic transformation. Similarly, you can go for anti-log, there also you can consider the lower ranges will not be considered there much, which may be discarded, but the higher range will be considered there, but still the dynamic range is made lesser. Okay. Now, as I said you, log function has its own limitations, like it has functionality with some base, defined base there, but if you go for any power, variation of any power of intensity values which are maybe in this fashion, say r to the power of gamma, again the c which is considered here, that is only a constant or a scaling factor, nothing else. But basically it is S is equals to r to the power gamma. R is the intensity, input intensity value, and gamma is the power of it. And this kind of transformation will be called power law transformation, where the transformation is dependent on the power of input intensity value r. And since it is used gamma, sometimes they say gamma law transformation also or gamma correction also sometime. Why the correction term is coming, I will speak in the next example. But first let me discuss about capital T R. So, what is capital T R here? There is nothing but gamma transformation or the transformation of the input image through power of R as gamma. Okay. With that, C is the multiplication factor considered there. Now, if you consider different gamma values starting from fractional to the integer values. If you go for gamma equals to 1, what you will get? Purely straight line. S equals to R, say C equals to 1. S equals to R, purely the straight line of angle 45 degree. Now, you go for fractional gamma values or more than 1, the curvatures will be there and it is flexible to you to take any value of gamma there. Okay. So, depending on that, the curvature will be defined there. Now, this is about the mathematical part, purely the mathematics. Now, what the curvature basically says, if the gamma value is low, means very low, in that case lower intensity values will get much push compared to the higher gamma values. Go for the up fractional values. As lesser and lesser gamma, the curve is more and more steep to the lower end. Similarly, opposite thing you are getting for the gamma values more than 1 there. Okay. So, this way if it is your desire to have a transformation of this kind, then you decide the gamma value which is to be taken there. Up to this, these are purely mathematics. Now, let us go for the actual practical application of this gamma law transformation, then things become more realizable or more interesting. How? Just like say you have some mechanism there. Basically, this is an example of cathode ray tube, where electrons are released from a tube and those hit to a plate which the phosphor will be kept, and those will, after hitting, they will be releasing the lights there and you will be seeing the image there. Okay. Those electronic devices, they apply a electric power there, so that electron release there, if it is more electron released, more electrons will be hitting to the phosphor screen and more light will be coming there. So, intensity will be higher there. So, they feel like that, okay, if I want more intensity to present, I will release more electrons. So, they followed the curvature like this. That means more intensity means more power will be given there and more intensity will be expected there. But unfortunately, they found there in this way, if they follow the mechanism, the output is coming like this, where lower side is very dark and higher side has got some intensity values there, but not that prominent, and the variation of the intensity values are not that attractive, which was supposed to be there. Okay. So, this became almost useless. If you linearly increase the number of electrons there to hit more phosphor to increase the intensity values, what might be the reason? Then they analyzed those and they found that actually the improve of number of electrons there and the intensity increment are not following the linear curve, but they are non-linear. Actually, after analyzing the image, they found that the curvature comes this way. So, if you want to get the highest intensity value, you have to get the input in electrons released much more compared to that what we wanted there. Okay. That means you have to follow the curvature not linear, but of that kind. but I wanted a gradual increment of the intensity values there. Now they found that that curvature, if it is so, let us mathematically represent that, this nonlinear curve. Then they found that that nonlinear curve is just like 1 by gamma value. Gamma is of some integer value there, say 1 by gamma, or some gamma is of fractional value, or the power is of fraction, for which the intensity values are varying that way. So, if I want to vary the output as per my desire, so if I multiply this R with gamma, so 1 by gamma into gamma, it becomes 1. So, as per input, the output also will vary whatever we wanted there. So, they found that if this is the actual happening, then let us use the opposite one, just like inverse of that. Since it is coming actually as 1 by in form of 1 by gamma, multiply it prior with gamma, so that it becomes actually R at the output. So, this kind of correction is called gamma correction, because by multiplying the gamma, you are able to correct the image, and finally you wanted to get this. Unfortunately, you got that one because of that nonlinear transformation, but prior to that, to cancel the nonlinearity, you use a nonlinear function for correcting that, and finally you got this image which is actually expected for us. Okay. So, this way the gamma correction is important for image processing there also. If the actual image was formed in that fashion, but actually the image will be of the other kind, then without handling the electronic device, you can process it in your computer itself to get the actual one, if you know the image which was given to you, that was actually transformed through 1 by gamma there. Okay. So, this is in their device they have done, but if they say that actually the image was supposed to be like that, because of the limitation of my system, the image what I am giving to you, that has that kind. So, there I am seeing you that my system has a limitation where the outputs are actually R of 1 by gamma. You will quickly multiply it with gamma and you will get the actual one through your processing without disturbing the actual electronic system there, or not necessary also to visit the actual electronic device there. Okay. So, this is nothing but enhancement of the image through the power law transformation. Few more examples I can give for this power law transformation there, where this first block of 4 images here, if you see this image left top corner, this one and this one, if you compare there, in this part you will get some whitish part which was not at all visible for the actual image there. This, to obtain these images from here by using different gamma values which are mentioned there, purely by taking the power of gamma of this value to achieve this one. How could it happen? This is a purely nonlinear transformation for which the lower gray values which were dominating for the actual image, those were now given push to have the higher intensity values, so that those white parts, the variation here which was there here not visible, but they are now visible. That is through a simple operation which is a power law transformation. So, the image which was there without any enhancement, now through enhancement which could be analyzed here for finding the fracture of this bone, that could be done by a simple operation. Which way? Each and every pixel I have taken there, for the R values I have taken, and those are taken there for taking their gamma value of some specific value which are taken there in the example and process it. Each and every pixel are taken and gamma values of those as taken as the power and presented to you, nothing else in between. Okay. Purely like for gamma log transformation, what we did, the same procedure we will follow here, but the transformation will be here is the gamma. Similarly, at the very beginning I showed you that one image was there of like washed out, like it was not that prominent before enhancement. Similarly, the example is taken here where this image is like one smoked one, like somebody has given some smoke on it, or it is cloud has come in between while taking the picture there, but that is not, there is a foreign thing which has come there which is not desirable at all, but I want to wash it out from this place so that I get the actual image. For that also this power law transformation is again useful for us, but depending on those gamma values I can get the enhanced image which is given at the right bottom corner there in that block. Okay. So, this I said about only the transformation functions and their varieties, few of them are discussed here. Now, the question should come there, it is fine that you have transformed the image, you have got the image and function is defined there depending on something or some purpose, but how to tackle this in practice? Like if I get this image for a particular gamma value there, cannot I get better than this one? The question should come. Then what people do basically, they will use the image there, they will write the program there to operate for what, each and every pixel will be taken there and their intensity values will be taken, and then the gamma law will be applied or log transformation will be applied, and those will be repeated for different gamma values. If I write the program in such a way that it is gamma is kept as a variation as a variable for a particular gamma, I process the image and see is it good? No, then go for another gamma, then again get the another one. Now some better one will come from another gamma value, but how good, how better, that I cannot say. That you have to go for trial and error method there, and you have to ask the people, please see there I have got the image like this which was there earlier in this fashion. That is why I said there repeatedly at the very beginning that these are all subjective thing. The betterment what I am making here in enhancement, those are subjective. If objective measurement if you want, we have to go for another approach. Okay. We will continue this kind of discussion in the next lecture also for other transformations. Thank you.